Good morning, everybody. I am inside MathXL, a problem sent to me by a student, and it's a good one. The problem asks us to find an equation of the line. They give us 1 point, and then they don't want the equation we're going to find. They want it to be parallel to this particular line. Now, you know that 2 points define a line. If I had 2 points, you could figure the slope and create a line from that, and that line would be unique. Can't confuse it with any other line. It also turns out that a point and a slope define a line. So really, that's what we use this information for. We take this over here like I did, and we put it into y equals mx plus b format with some algebra. And now I can read off its slope, and that's really why that line's there, because the line parallel to it will have the same slope. So now I have a slope and I have a point, and that's enough to create an equation of the line. Now, an earlier skill that was given in this particular chapter was not to take a point and a slope and construct an equation, but given the equation in what's called point-slope form, find a point and find the slope. And I want to show you a trick that I use to do that. Now, here's an equation in point-slope form. And as you can see, this is going to be the slope. So I can read off the slope. It would be m is equal to 2. And now the question is, can you read off the point from that? And here's the game I play. I just ask myself, what value of x makes this quantity, this bubble, if you will, 0? And the answer is when x is equal to 5. So that gives me the x coordinate. And then I play the same game over here. What makes this particular expression 0? What value of y would make this 0? And the answer is -4. And so there you go. And I want to reinforce that by doing one more here. Of course, the slope is easy. It's what precedes this. In this case, it's going to be 1/2. And so then I ask myself, what value of x will make this thing 0? And the answer is -3. And what value of y will make this 0? And the answer is 3. So that's how you read off the slope and a point from an equation in point-slope form. And this problem essentially gives us a slope and a point and asks us to go back. And it's the same kind of game for me. I don't mess around with that formula, which is where all the student errors occur. Instead, I just play this game of creating things that go to 0 with a given point. Let me show you what I mean. Y plus or minus something, we don't know what it is, it's a slot to be filled, is equal to m, and we know that m is -6/5 for this particular problem, times a quantity x plus or minus something, we don't know what that is yet, it's a slot to be filled. And so the question is what goes here? There's two possibilities. It's either going to be y plus 7 or y minus 7. And which one of these, when you take -7 and put it in here, which one of these goes to 0? And the answer is this one. When y is -7, -7 plus 7 goes to 0. And so that's the correct form for this side of the equation. Over here I have my slope, and then again the same game. And there's two choices here. It's either going to be x minus 5 or x plus 5, and the correct one is going to be the one that goes to 0 when you put -5 in for x. And that's this one. And so that's what I put right here. Let's just verify everything. When x is -5, this goes to 0. So a point on this line is -5. When y is -7, this goes to 0. And notice that's the given point. And then here's my given slope. M is equal to -6/5, which is the same slope as the parallel line. Let me just show you why I think this is such an important idea. As we move on in this course, we're going to be dealing with parabolas, and we're going to put parabolas in vertex form. Y is equal to x minus 4 quantity squared plus 3. We're going to manipulate quadratic equations to get them into this form. This thing is going to look like this. It's a parabola. Be a very interesting curve. And the key point is going to be the vertex where it changes direction. The vertex is the turning point. And the way you find the vertex is to ask yourself, what value of x makes this 0? And you now know that's 4. And so when x is 4, right, this 4 minus 4 is 0, y is going to be 3, because this is just going to fade away into zerohood. and so y is equal to 3. And so the vertex here would be 4, 3, and I just found it not by going to some clumsy formula where I have to manipulate minuses, but by simply asking myself what makes this bubble 0. And to take it one more level, chapter 10, we're not going to quite get there in this course. You'll see that in college algebra. But here is an equation of a circle. X plus 3 quantity squared, y minus 7 quantity squared, I'm just making this up, is equal to 25. That would be the equation of a circle. If you put that into Wolfram Alpha and said graph it, you get a circle. And the question is, where is the center of that circle? Well, lo and behold, what value of x makes this 0? And the answer is negative 3. And what value of y makes this 0? And the answer is 7. So you put this equation in Wolfram Alpha and you'll see it's a circle with center at negative 3, 7. So this idea of asking yourself what makes a quantity go to 0 is absolutely huge. Not only in this course, but in your next course, and even in trigonometry. It is the cornerstone of my way of handling so many different things.